Good afternoon, everyone, and welcome. My name is Mark Reichman. I'm a senior research analyst here at Noble Capital Markets, and it's my pleasure to introduce Mr. Carl Johnson, Chief Executive Officer of Norsk Titanium, and also Asher Ashari, who's the Chief Financial Officer. And following the presentation, we'll have about 10 to 15 minutes of Q&A. Carl?
Thank you. Appreciate you all coming. Norsk Titanium is an additive manufacturing company that has a different business model than you might think of. We do not sell machines, we sell parts. And we sell parts into the aerospace and industrial sectors. If you look at forgings, it's gone the route from blacksmith to big forging presses to, which you can see in this lovely video that I am not showing because it's not hooked up. Our facility uses an additive process. It's a very clean, quiet, energy efficient process. I think I show you a little bit more. We designed our own machines. We have metallurgists that created the material process, and then we built machines that could perform that process. We offer 90% less machining time for titanium, less machining cost, and significant savings to our customers. We use less raw material. What we produce is a near net shape part that has the material properties that titanium needs. The customer or downstream supply chain for us does the final machining. That's necessary to get FAA and EASA approval for flying parts. They have to be fully inspected. So far, we've qualified for the commercial aerospace market and defense, so Boeing, Airbus, and a couple of defense contractors. We have installed capacity of about 700 tons. I'll go through that of deposition a year. And our process and materials are covered by over 200 patents. So we spent 10 years developing our process and our machines and installing them. And now we're at the point where we've qualified and we were beginning to transition parts into production, serial production. So our facilities in Eggeman, Norway, which is about an hour from Oslo, is where we do our R&D. We've got 3 machines there and 63 employees. And in Plattsburgh, we have our production center, which we do our commercial production on. And then we have a defense and qualification center where we can do DoD work. It's ITAR compliant and allows us to do work for the Defense Department. And we have 10 machines there. So this is not news to anybody, but labor, energy inflation creates a need for a more efficient process. Diminishing titanium supply, with Russia being off the table now, brings you to a need for a sustainable process that uses less titanium. We began targeting aerospace because it's the hardest market to get into due to the qualification. And if you look at after the pandemic, the recovery of aerospace, all of the OEMs are increasing their production rates. There are two platforms, the wide bodies, A350 and 787. I expect to add 200 airplanes a year in the next couple of years. The total market for commercial aerospace is about 46,000 planes over the next 20 years. We're in our addressable markets with the machines we have are commercial aerospace, defense, and industrials. And I'll go through some details on that, but our customer base on the right side there is Boeing, Airbus, Northrop Grumman, General Atomics, ASML from computer chip machine manufacturing, and their machining partner, Hittech. So we've been in business since 2007, developing the qualification, the process, and the machines. In the first half of 23, we had 8 parts in production on 787. By year end, we had added a couple of parts from Airbus. In the first half of 2024, we had totaled 26, and we currently stand at 54 and expect to be at 60 parts by year end. So the milestones through the year: getting the Airbus qualification, a master supply agreement in place. Once you get through the engineers, you got to get through the supply chain business guys. We've done that. We got a direct supply agreement with Boeing. Our target is not the prime, Boeing and Airbus. It is their tier ones that actually procure parts and do the assemblies. We started making parts for Hittech. They supply to ASML, one of the largest chip machine manufacturers in the world, and we began defense. So starting the end of the year here at 60 parts, the annual recurring revenue that is generated from that is $15 million. You take the sales price times the number of parts produced per year by the number of years of your contract. Typical aerospace contracts are 3 to 5 years. We've renewed the ones that we've had beyond that. We expect to be at 120 parts by the end of 2025 and at over 200 by the end of 26 with a revenue of $160 million. We've transitioned some parts recently. The difference in annual recurring value is we want commercial because they're high volume. Defense is good, there's good margin. However, the production rates are typically low. On the Airbus side, we are supplying parts for the A350. The A350 has the common thing between the A350 and the 787 is they're composite airplanes. Composite airplanes require a titanium interface to other structure because of the corrosive nature of the resins in the composites. You can't use aluminum, as they found out. They replaced aluminum with titanium. So in the A350 and the A320, there are more than 500 addressable parts that represent about $1 billion addressable opportunity for us. Get the right switcher. The 787, we currently have 7 parts flying on every 787. We've delivered about 2,500 parts to Boeing since 2017. We've renewed orders through them. There are about 1,000 addressable parts on the 787 and about $1.5 billion in total addressable opportunity. On the DoD side, we have parts that have flown for Northrop Grumman. We have parts that are in the queue to fly. We also have delivered parts to General Atomics. General Atomics makes unmanned aircraft, and we've delivered critical parts to them. We're also doing work with Bechtel on nickel superalloy. Also very hard to machine, has a good value proposition for us with near net shape. That development also takes us into a product for oil and gas. Anything in a highly corrosive environment, nickel steels or nickel alloys are used, as well as titanium, but in oil and gas it's more of the Inconel type parts. In the industrial side, we work with Hittech. a machining house that supplies the tray that you see in the corner there that's about 10 kilograms when it's finished. They had been doing that, doing the machining out of a 220 kilogram block, a lot of waste, a lot of time printing. We deliver them an 80 kilogram print. That's up the capacity that Hittech has and by reducing the amount of machining time that they require, and they get exactly the same part out. I'm going to turn it over to our CFO for the financial projections at this point. That's the guy.
Thanks. So from a financial projections perspective, we guide to a 2026 number of $150 million in revenue in 2026. Our commercial forecasts are developed in conjunction with our customers. So all the customers Carl just talked about, we've identified parts that are going to transition into production over the next year. So we spent 10 years getting to the point we are today to get qualifications in place and ability to put our material on planes. So now we're working with the customers to transition those specific parts into production and serial production. So our forecast by 2026 is about 150 million. That means that we're going to produce about 41,000 parts. That's more than about 200 unique part numbers in production. That only utilizes 50% of the capacity we have available today. The $150 million in production gives us about 30% EBITDA margins in 2026. So one thing is Norsk Titanium is fully funded to execute on the current business plan. What we're going to use, so we recently raised, as of last week, we raised another $13 million through a warrants issue and exercise of the warrants. That gives us a cash position of approximately $30 million in the bank today. And that's sufficient to get us to the 150 million in revenue that we're targeting in 2026. What we are doing with the capital is we're leveraging our success in semiconductor industry and diversifying our sales into industrials in addition to bringing aerospace parts into production. Where we have a very regimented and disciplined approach to cost and production costs. So we align our hiring growth and our operating costs and production costs to roadmaps that we've laid out already as volume increases. What we are doing also is looking at evaluating certain working capital financing facilities to have some financial flexibility into our plans. But as of today, we are fully funded to where we need to go. So in summation, there's about $450 million of capital invested in the company. 325 million of that is from equity. 125 million it comes from a New York State grant that built our facility for us. The market cap on this is a bit stale. As of this morning, it's about 180 million in market cap. We have 35 machines available to us. That gives us 700 tons of print capacity for our customers. We are a part supplier. We don't sell our machines. Our print capacity can get us about 300 million in revenue when fully utilized. And our whole process is protected by over 200 patents. Which also takes us into kind of having the material specifications available for our customers to transition parts into serial production. So we're present in 3 markets, and we're active in all 3 of our markets that we targeted. Questions?
Well, I wanted to just start off with your forecast. I know that the aerospace market was a little soft, so some of the projections have kind of moved to the right. But when you go from 2024 producing 60 parts to 200 parts in 2026, what's your capacity utilization look like?
So by the time we get to 2026, we're using about half of our capacity that's installed. Our machines in New York were purchased through a New York State grant, and the facility they were that they're in, our obligation back is $1 a year in jobs. So we have installed capacity for about 300 million, and we're talking about 50% utilization.
And then just a second question, just how to think about growth. So you spent a lot of time on this qualification process, and so now you're in.
Yeah.
So are you good for the life of, say, that aircraft program? And, you know, any new parts, so it's almost like a cumulative story here, and your parts will always be used as a replacement?
So there's 10 years of getting qualified. And so far, we're the only ones that have qualified to the Boeing and Airbus spec. We're at a point now where we're taking on new parts. You saw that we went from 11 parts at the start of the year to 60 parts at the end of the year. Those parts come with about a 3 to 5 year contract. We've been in production with Boeing since 2017. We've renewed those contracts for the 787. When they make a transition to our parts, because it's a new process, that requires a change to their engineering. Our value proposition has to cover the cost of that change as well. So there's quite a barrier to entry to change from us once we are in. So as we're getting new parts, we're also creating a barrier for others to come in. Yeah.
Is the methodology molten titanium?
So we take wire and we melt it into onto a piece of titanium that gets to be part of the final part, and we lay down strings of titanium that approximate near net shape the finished part. We leave extra on purpose so that it can be machined, and it just lays down. It is basically a welding process. The application is new, the process is new, but the technology is welding. Plasma arc welding.
What are your main competitors, please?
I'm sorry?
Main
What are your
competitors.
main competitors, please?
So in terms of selling parts, it's forging houses, the people we're trying to displace, right? And in terms of, and I would say that's the primary because that's who's on the airplanes now, right? That's who we compete. When we submit a proposal for parts, we're competing against other forging houses. In terms of looking at additive companies that are close, we are the only ones that have qualified. We estimate we're about 5 years ahead of our competitors in getting to that qualification.
Once they have a technology. to
Once
qualify.
they have the technology.
Yeah.
Yeah.
What is your current cost of capital? What's reasonable for a firm?
That's a good question. And when we look at the market cap in terms of the capital that's been invested, you can't really measure it in that sense. We don't have any debt facilities in place right now, so it's a hard question to answer in that respect. But it is whatever the cost of equity is at the market cap it's at today. So that's the best way I can answer that question.
I know you're dealing with critical, kind of very critical, high margin parts. So, and the qualification took a long time within the aerospace, which you got right in. But how would you compare that to margins and the difficulty of getting in the qualification process, aerospace versus defense versus industrial? Is some of what you've done in aerospace transferable?
It's all transferable. Our process that we developed for commercial aerospace is directly applicable to the DoD Air Force side. At the same time we were qualifying for Boeing and Airbus, we were also talking to the U.S. Air Force. which is how we were able to qualify for Northrop Grumman's. The industrial side, we get to scale back a little bit because the qualification is less. We were able to bring on the parts for ASML quickly because quite frankly, the specification that we wrote and got released through the Society of Automotive Engineers is a specification that they buy to, and qualification wasn't required because those values in the release spec were adequate for them. So that moves through more quickly. We have the opportunity in industrials to move to lower cost wire and plate. So for aerospace, all of our wire is sourced from the US. For industrials, we have the opportunity to source wire from China at a lower cost.
Yeah. And
It's a lower grade wire, but it's adequate for that market.
Yeah. So I'll just add to what Carl said in terms of margins. Industrials is an interesting opportunity because there are shorter lead times to get parts into production, right? You don't have to go through the rigorous. We've established these material specifications, like Carl just said, that gives us kind of the license to operate, essentially, right? In terms of margin, like Carl was saying, industrials gives us the opportunity to move from expensive aerospace grade materials in titanium to Chinese procured lower quality materials in titanium because it doesn't carry the same amount of stringent requirements, right? That improves the cost margin significantly. However, industrials also struggles with being a lower cost market, right?
Yeah.
So moving to lower China, I say Chinese, but it doesn't have to be.
Yeah.
Well, but gives us high volume, low cost, but we can also low price competitive, right? So it's price competitive, and we reduce our production costs by moving to lower cost materials. Yep.
Yes.
With more than 6,000 small and micro-cap companies listed, if you're looking for the next Apple, then ChannelCheck truly is your tree. It's an investor community where you can access independent Wall Street research, advanced market data, balanced news, corporate videos, and podcasts. You can even register to attend in-person Meet the Management Series luncheons, and to be part of the preeminent annual Small and Micro-Cap Investor Conference, NobleCon. And here's the best news. Since ChannelCheck is sponsored by the featured companies, premium membership requires no investment. It's absolutely free. So check it out. Log in today. Find out why ChannelCheck is North America's leading source of research on the companies that just may change the world.